that we're actually live. So, hi, Christian. How are you doing today?
I'm good. Thanks. Nice to meet you.
Thank you for meeting us, the X Future, at this Future Friday event. And for the audience that's joining us today, I wanted to introduce Christian. Christian is the founder of Threedy.io. Essentially, Threedy.io is a startup that masters transforming the future of 3D modeling, taking any data into interactive experiences. And you just started 3D.io less than a year ago, is that correct?
That's right. We founded the company in October last year, but we've actually been preparing it for quite a number of years already. And we're building on a technology that's been developed for almost 10 years now.
So I read a little bit about you, and I saw that you have a very rich background. Essentially, you're a software engineer, but with an extensive experience in research in visual computing. Is that correct?
Yeah, so from my first studies, I was always interested in 3D computer graphics. And after my bachelor, which was focused on software engineering and 3D data visualization, I joined a company in the games industry, a studio from Electronic Arts, for a few years before starting my master studies and joining in the course of my thesis the Fraunhofer Institute for Applied Computer Graphics Research in Germany, in Darmstadt, in 2012.
Okay, so pretty much dedicated your life to this passion of yours.
On the working side, yes.
Okay, very interesting. We'll also want to know a little bit about you. That's not just about the work, but we'll get to it later. So I think as we get started, I wanted to hear a little bit about what got you started with Threedy.io. And before we dive in, I just want to say, in these type of interviews, Future Friday, what we do is we speak exclusively to Industry 4.0 type of startups. Usually we'll be talking with a very technical founder, co-founder. Today we're speaking with Christian, who's the CEO of Threedy.io. And usually it's a very interesting conversation because we're dealing with a technical solution that can be very, very horizontal. So we'll probably be diving into, very specific use cases of what you do for, the companies that you work with and providing solutions for. But the way that your solution can probably be used is as much as the imagination can afford. So I want to really unpack this today as we speak. And now I'll let you answer that question that I asked you. What got you to start Threedy.io?
Yeah, so when I started at the Fraunhofer Institute, I joined the group of Dr. Johannes Beer, which was called Visual Computing System Technologies, and was initially founded to support the more domain-driven departments with space technology. So at that point in time, there were two solutions already in place. One was the instant reality framework for distributed rendering solutions, for example, for cave environments. And the second one was open source JavaScript library to visualize X3D-based scene graphs directly in the browser. And so our first ideas spun around opportunities to kind of combine these technologies as a end-to-end solution from the browser as a client to a server-side preparation, optimization of data, and allow people then to build their own applications on top. And so initially, this was kind of a, let's say, research idea where we started to write papers about. But then in 2013 already, the topic became some traction because we were able to win an official tender by the BMW Group about bringing their JT Jupyter tessellation data to the browser. And at that point in time, I think the whole topic became a new perspective, because for the next years, based on this initial funding, we kind of grew the development team internally that was building this technology to provide all the required functionalities to be an actual contender in this industrial use cases. And so over the next years, we were able to win additional companies as direct licensing customers for the technology. And as part of that, growing the team from 5 to almost 20 people. And so based on this huge industrial success, we kind of in 2015-16 started spinning our heads around the idea of creating a spin-off company. And at that point in time, it was already clear that this is not going to be a very easy task, because of the complexity of the whole situation, where there was a huge interest in the technology from the side of the research institute. There were these industrial customers that kind of wanted to understand about the roadmap, that wanted security if they start building their applications with the technology. Who can guarantee them that it's still going to be available in a few years, but also that it's going to be maintained in meeting their standards, because that's obviously not what the research institute can do. And so initially we applied for Fraunhofer internal spin-off preparation programs. And then I think the most important part was that we got a public funding by the German state, the so-called Exist Research Transfer, that allowed us to then really invest a lot of time into building up our idea on how the company would work, prepare the necessary negotiations also on the Fraunhofer side on how to get a license for the exploitation of the technology, and also prepare the transfer of all our employees, of our development team, our staff into the company. And that finally was successful then last year. So we were able to spin out, and also maybe the most important part, to convince these industrial customers to switch over to the new company and actually kind of renew their licensing contracts with us. And this is kind of the foundation for Threedy. On one side, these relations with long-term customers. On the other side, the development team that by now has completely transferred into the new company, and gives us a lot of traction on one end, but also a good backbone for future developments.
So you could say that that really helped remove these objections of, what's going to happen to the solution, who's going to support it, is it going to be maintained, is it going to grow with our needs? Did that really remove all these barriers?
Yeah, I think it was about constant communication and keeping everyone on board, keeping everyone informed, and stating our plans early on. And then actually, bringing them or realizing those plans that kept up the trust for these customers, which are essential to our company.
So do you feel like now would be a good time to tell us a little bit about the problem that your customers are experiencing?
As you mentioned, it's really a horizontal technology in the sense that people are not using it for one specific application or use case scenario, but it's rather an enabling technology for the digital transformation of our customers, where the importance of 3D data is really key. And so what we experienced over the last years is that there's a number of challenges arising when bringing 3D data into industrial applications. And to name 3 of them, the first and maybe most important one we see is the explosion in variation and complexity of 3D data sets, where over the last 20 years, people have moved from a single data configuration, a single car model that has been built exactly like this, millions of time maybe, to individual product configurations where each individual car that you see on the street has been configured to the customer needs and maybe to the needs of the automated assembly that's actually been building the car. And so if you look at numbers, for example, for configurational options for the harness configuration of a car, this goes from a few hundreds into the billions of potential configurations. And you can imagine that for all these later on processes like making data available to the people in the workshops repairing these cars, this is just a huge problem, because you can't generate all this information up front and then make people look up the data they need once the car is in front of the workshop. But you need automated ways to provide this kind of data based on the original truth in the product lifecycle management systems. The second thing is that we see 3D data as really a key asset to the digital transformation, but the way 3D data is integrated has been getting more and more complex over the years. So like some 20 years ago, people typically have been using monolithic application platforms where it was more of a process world, where people were using expert tools to work with 3D data, and then typically had documents as their artifact. Like you start your daily work based on a document containing 3D data, you're modifying it, and then the resulting document is the artifact that's moved through your process. Whereby now people are including the applications in this continuous data world of services, where it's about flexibly and dynamically integrating at runtime data from different sources with each other to generate the most important business information. And in these modern worlds, the provisioning and management of 3D data based on file artifacts just doesn't work that well anymore. Before diving a little deeper into the solutions people are building by now, the third aspect is really making 3D data available all along the value chain, where before it was mainly focused on the construction and design or the production environments. By now, the requirement really is to make this full complexity, the original truth of your data and all the information that has been attached to it through your product lifecycle, through your different processes, make this available to anyone who needs this information to really get the most quality and business value out of your 3D data. And so the core issue that we are seeing is that in order to solve this problem, what our customers typically do is that they are building conversion pipelines for data, where typically you start with some mathematical descriptions, defining the surfaces of your geometry, for example, and then for collaboration and for making data available further downstream, people then often have collaboration formats which kind of try to combine 3D and business data in a specification that brings all this together. And then data is distributed on these first derivatives. But then the further you get in the product life cycle, if it's about marketing, high quality visualizations, if it's about defect detection and documentation, if it's about maintenance, and by now often then mixed reality applications, the environments change in which the 3D data is used. So from the typical CAD environments, there's a trend to move through 3D PDFs, for example, to really high quality rendering solutions with a lot of manual preparation steps, or then Unity, like game engines, or Vuforia, like specific AR authoring solutions, where there's typically a restriction on the formats and the level of detail that the data can contain to be viable, to be viewed in this environment. And the reason for that is the high interdependency between hardware capabilities, like the performance a device can deliver, between the actual software environment, specifically the rendering algorithms that generate pixels out of your data, and then the size of your model. And a good example for this is, if you have been following what Microsoft has been doing with the HoloLens, is that they define certain limits that are supported by certain software solutions. So for example, if you want to render your 3D model directly on your HoloLens, Microsoft tells you go up to 100,000 triangles. Everything else, do remote rendering in the Azure cloud. So this leaves the actual application developer with a decision, okay, I'm going to build my application now. Which of these two technology stacks should I use? And then once the data changes, your approach is potentially not going to work anymore. And in these industrial environments where our technology is used, it's all about automation. So you need to automate the way from the people who generate the data down to the consumers. And you cannot take care about these kind of limitations, because that brings you directly the need to build up these conversion pipelines, but also then brings up the issues that are identified with this, which is starting with the management. So the file-based distribution and management of data is something that really costs a lot of efforts. But then as part of these conversion pipelines, typically the data gets stripped out, of a lot of the elemental information, starting with a structure. So for example, big assembly information trees or bill of materials are stripped down to just single entities to fit the runtime environment's need for the data complexity on that level. The geometric details are stripped away, so often surface information get baked into textures and then mapped onto the surface, so that the appearance might still be the same, but the information about the original surface complexity gets lost. And then most importantly, metadata and relations in the data, like product manufacturing information, get removed. And so people in these applications, once they have made the data available, they just cannot get the original value out of it anymore. And on the other hand, these pipelines, once they have been built, which is an expensive task by itself, there's a lot of costs involved to keeping them up to date. There are different update cycles for all the software components involved. So there's a lot of efforts, even manually involved, to keep them in place, keep them working, and keep the data available.
Can you talk through a few examples of, we talked about the data a lot, how you, the reason why you generate this data, and then what you do with it and how you can use it or not use it. It sounds like these are the big problems. I'm trying to, learn from you, what are some main uses of the data, right? What would BMW use that 3D data for on their day-to-day actions, operations?
Yeah, maybe starting with a small hint to your introduction, where you talked that we provide a solution for modeling the data. That's not exactly true, because we are rather only visualizing the data that's existing, and we allow people to build information on top. So in these modern software environments, it's often about making your data available and then accumulating information on the next higher level in every later stage of your process. So what people are doing is they use the technology to, as the core part, make the data available for the applications that they want to build. So in the past, building a solution with 3D graphics involved typically required that you have engineers on your side that understand the very details of generating pixels out of data. But with our solution, people can start with a simple web developer who understands HTML and some JavaScript to still get the full complexity of their data into applications that they are building. And then there's just a variety of use cases, which range from really complex applications where, for example, it's about repair guidelines based on step-by-step procedures for the after sales, which can be even used with augmented reality. And on the other end of the spectrum, there's simple review applications where it's about sharing a link to a 3D session with your coworker so he can review the changes in the data and sign off on those. So it's really a broad spectrum of applications. And we even give people the flexibility to decide themselves what they want to use as a base application technology, ranging from the web browser, who's maybe the most important part of our solution as a front-end technology, through native and Java solutions to down to game engine-based solutions.
But for our technical listeners, I want to dig deeper into what the data is used for. So, for example, is it used for quality assurance on the assembly line, for example? Would that be one application of how the data is used?
Yeah. So as I said, there is a variety of solutions, but we are not building them. So typically over these years with our customers, we had a number of projects where we brought the integration with the PLM systems to a certain degree, because we can there directly connect to the user management and the authorization systems to make sure that only people allowed to see the data can actually then use it. And on the other side, we kind of provide a number of basic tools, typically in the area of digital mock-ups, which we deliver the full typical feature set in our default applications, but then people use the underlying APIs to build applications themselves. And most of the time they employ additional service partners or companies to build those solutions, and we rather do only a consulting part of it.
Got it. So you're really just providing the technology, and then the customers add their own layer to that.
Mm-hmm. Exactly.
Okay.
And so I think this example that I mentioned before about automated repair guidance in the workshops is an example we built with Porsche. And there's just typically in these scenarios, there's a number of customers or companies involved. So on the data management side, there's typically Siemens, often in Germany with the Teamcenter solution. There's an AR-related authoring tool involved. And then there's another company that builds the actual application with the Porsche branding and everything that's then used in the workshops. And we are kind of the data pipeline that makes the data available for every employee in the workshops, and that's able to consume this data, to load it on demand, and visualize these repair guides and even augment them on the real cars.
Got it. So you want to tell us a little bit more about the solution, how you solve it, how you provide the solution on top of everything that you've mentioned so far.
Yeah, so as mentioned before, it's typically directly integrated with our customers' PLM system and data infrastructure. So the flexibility to connect to a number of data sources at the same time and bring the data of different silos and different formats together is really one of the key aspects of the technology. And by now, we typically, based on the licensing contracts, provide the technology on premise, so it runs on the bare metal of our customers. But with our latest version switch, the 3.0, we made the technology cloud native, based on Docker containers for the individual services and using Kubernetes as a scalability layer. And this really now paves our way for a real software as a service solution. So one of the big steps for our company is going to be to really figure out the evolution of our business model to in the future make the solution available based on typical public cloud providers, or the private clouds of the customers, where currently there are already endeavors to switch from the on-premise installations to those.
And are there any other such solutions in the market, like competitors?
Yeah, so on the competition side, it's really difficult because if you bring up Threedy in your Google search, there's just so many out there. So historically, I think we compete a little bit with the typical visualization solutions as part of PLM platforms like Teamcenter or 3D Experience from Dassault, or PTC solutions. Then if you move forward to the mixed reality corner, it's the also typical solutions like Vuforia or game engine based solutions. So I think what really makes us unique there is that we kind of bridge the way from the data to the applications, and we take away the need for the application developers to take care about the data quality and the way the data takes to be made available there. So there is, I think at this point in time, there is no solution out there that's directly comparable to what we are doing.
Got it. Yeah, and that makes the difference. So can you tell us a little bit about the solution in the wild, right? What are we seeing? What the customers are able to experience, the benefits, and so on.
So you have to, I think one has to understand that it's really about the flexibility of changing the way your data is made available or how it's consumed. That is the core value for the customers. So in the past, I think, on your process side, defining and maintaining the flow of data has really been a costly effort, because often through the product lifecycle, at a later point in time, people find issues in the data, for example. So something cannot be assembled the way it was constructed for some reason. And then getting this information back to earlier stages and doing the required changes and then communicating the changes and getting them verified later on in the chain is really a big issue, because in between the typical formats might have changed, information might have been lost. People are just not talking about the same truth of the 3D data. And this is, I think, the core part, what people love about the technology, that at any given point in time, you can just fire up a session. You can bring these variants of your data together. You can combine it with other core technologies people are building, where it's on the high level, for example, about using linked data architectures to connect data through silos, and use our technology then to kind of solve the 3D part of it. And on the low level, it's really about easily bringing information that you compute based on your data. So, for example, complex difference calculations on complete car assemblies, and bringing these resulting report informations together with a lightweight visibility viewing solution based on a browser-based application. This is the flexibility that we bring to people who build on the solution, and then the ideas typically come from our customers. And at the same point in time, making the switch to a virtual or augmented reality as easy as sending around a link and consuming it in a different environment, a link to a pre-composited 3D space combined with business data, and then consuming that, for example, in a game engine. That's ease of use and the flexibility that the customers just have not seen before.
And how soon can they, when you have a potential customer, and they're looking into the solution and trying to assess, the value and if it's the right solution for them. So during the sales process, how soon can you show value to the customer? What is the process? Do you do a POC or a pilot? How does it work?
Mhm. Yeah, so in our time at the institute, this typically was rather a long process where we spent often several weeks or months to build together with the customers these first kind of integrations. But this was maybe also one of our key steps forward, that we not only have standardized APIs throughout these various front ends, but we also have a standardized way on how to integrate the data, which is called a data gateway, and which can be configured in our system. And the easiest way to make data available, to consume it in the front ends, is just delivering it on a web service or putting it behind some REST interface that you then configure as part of your installation.
Got it. So yeah, it required essentially also simplifying the cost breakdown with something like this, which is very much, like usage based. So a customer can't really know what's it going to cost, and they need to know in order to, factor that into their decision. Okay. I think you've answered most of my questions. Well, I really appreciate your time with us today, Christian. Thank you so much, Christian. Have a great day. Bye.